I've been teaching maths for a long time, and every once in a while you'll get a topic that you start to really like. Turning recurring decimals into fractions is one of those topics. I don't really know why I like it so much, but I fucking love it. So let me show you how it's done. First of all, if you've got these two dots above the 8 and the 1, that means that those two recur. So this number effectively is 0.681818181. It just repeats between the dots. So what we're going to do is we're going to start with x equals that. X equals 0.6, and we'll write it out a few times with that cycle. 818181. Now, there's a shortcut method or a long method. I'm going to do it the long way because I think it's less chance of making a mistake. But once you get more confident with it, you can kind of skip to the step that you're confident about. Now, we're going to keep timesing both sides by 10 until we get to a value which is exactly the same after the decimal point. I'll show you what I mean. So let's say we've got 10x here, and we're going to times this side by 10. So that's going to be 6.818181. Now, after the decimal point here, it's 681. Here it's 81. They're not the same. So let's times it again. 100x. It's going to be 68.1818. Again, after the decimal point, none of these are the same. 688118. Let's times it again. 1000x equals 681.8181. All of a sudden, look at these two. 0.81, 0.81. Those two are the same after the decimal point. So what we're going to do is we're going to minus them. The reason why this works is because it's going to eliminate everything after the decimal point. So that line minus that line. 1000x minus 10x is 990x. 681.8181 take away 6.818181. As we said, everything after the decimal point will cancel out. So it's just going to leave us with 675. Now all we need to do is divide both sides by 990, therefore getting the x by itself. Because as we wrote at the very beginning, x equals this decimal. So if we divide by 990, it's going to be x equals 675 over 990, which is the unsimplified version, and just plugging that into your calculator or doing some step-by-step cancelling out of these, dividing by 5, dividing by 25, well not 25, but dividing by 5 and some various other numbers, we will end up with 15 over 22 is the final answer. So because x equals this, and we've worked out x equals that, therefore that equals that. So let's do another example. Write 0.216 recurring, and we've got the dots above the 2 and the 6, which means it recurs between those two. So it's going to be 0.216216. We always go back to the first dot and finish at the last dot to find out what the repetition is. So let's write out x equals this with a couple of repetitions afterwards. 0.216216 and another one for luck, 216. And I'm going to keep timesing by 10 until we get to the same values after the decimal point. Now this is where the shortcut can come in. We can see it's repeating 3 times. So after we times it by 10 3 times, it will become 216 again. So we can kind of sneak forward those 3 steps and jump straight to 1000x, because that's what timesing it by 3. So that's going to look like, if we move the decimal point 1, 2, 3 times, 216.216216. Now we do the same thing as before. We do this line minus this line, therefore eliminating all of the recurring decimals. So 1000 take away what is effectively 1x is going to be 999x equals, all of those will cancel with all of those, and we do this minus this to leave us just with 216. Then we make x a subject because x is, after all, the original decimal. X equals 216 over 999, and of course we always try and simplify it as much as possible. I know we can divide this by 3, probably by 9. If you've got a calculator, then obviously you can just plug it in, but more likely than not it's going to be a non-calculator test. So just be really careful about dividing the top and bottom by the same thing. I'll just tell you that the answer does come out as 8 over 37.